Okay, let's look at the trace of one more recursive method, and this one uses arrays. So I want to reinforce something we talked about earlier in this semester, which is how arrays are treated in Java. So here you can see that we have a recursive method that takes in 3 parameters, one of which is an integer array, one and then 2 normal ints. So remember that when we pass any variable in Java, Java operates with pass by value. That means the value of that variable is passed and assigned to the formal parameter. Now, the tricky part comes in when we deal with objects, right? Because for primitives, that's pretty simple. The value of the primitive variable, like an integer or a char or a boolean, so that value for 7c or true, for example, gets passed and stored in the formal parameter. The tricky part comes in when we deal with objects because, again, the value is what's passed and stored, but remember that that value is a memory location because that's how Java stores objects. It stores a memory location, a pointer to somewhere else in memory where all the information about that object is stored. And arrays are objects, so that's how arrays are passed as well. So before I invoke this method, I declare an array called A that has 5 integers in it. And so I'm going to represent that here, that somewhere in my little memory here, there is an array that is stored with the values 3, 2, 1, 2, 3. Okay. I apologize, this is a bit of not a pretty picture, but this is the best I can do for now. Okay, so here is my array that I've declared. Okay, so let's now go through our method invocation, keeping in mind that somewhere in Java there is this array with a reference A that points to it. So let me actually add that reference too. So we have A, and what is stored in the value of A is a reference to somewhere else in memory where the array is stored. Okay, so now let's invoke our method, recursive method 2. So we get an activation record for rec method 2, and we have 3 parameters. We have R, B, ARR, B, and C. So R gets passed the value in this first call that we're going to trace. R gets passed the value of A. The value of A is a memory location. So that's what gets passed to R, like that. A new copy of the array is not created. We still only have one array, and what we do is we pass the memory location of that array into the formal parameter. That's the value. The value of A is this location, so that's what gets passed. And then B gets passed the value of 2, and C gets passed the value of 0. So this is our method. We put this method on the stack. Okay. And, sorry, again, this picture is a little ugly, but hopefully it does the trick. And now we can start going in and evaluating our method. So we hit an if statement. If the value of C, which is 0, is less than r.length is 5. That's true, so we come into this if statement. Now we have another if statement. If the array at position C, so C is 0, so that would be 3. If the array at position 3 is not equal to B, it's not. So now we hit a return statement. We return, but what are we returning? We have to wait because we have another method invocation. So we have another method invocation, so we get another activation record, and we're now invoking rec method 2, and our formal parameters are R, B, and C. R gets passed the value of the current ARR, which is an arrow. This is going to go on the stack. So again, we get past another memory location, the same one, so we now have 3 different variables or parameters that are pointing to the same place in memory. B gets past just the value of B, and C gets past the value of C plus 1. So C is going to be past the value of 1. And this method is now the top one on the runtime stack, so we'll go ahead and execute this method. We get in here, is C less than array.length? Yes. Then we get in here, is the array at position C, which is 1, is it not equal to B? That's false because it is equal to B. So we jump down to our else. Our else is a return statement. We return 1 plus, oh, wait, we have another method invocation. So here we get another activation record to go on the top of the stack. And our method here is recursive method 2. Our formal parameters are ARR, B, and C. ARR is again past the value of our current ARR, which is a memory address. B is past the value of B. And C is past the value of C plus 1, so 2. Now we start executing this method. So we get in here, is C less than array.length? It is. Okay, is the array at position C, which is 2, which is this here, is that not equal to B? That is true. So here we hit a return statement and we're returning up. Wait, I don't know what we're returning because it's a method invocation, so I have to invoke that method. So I have a new activation record for rec method 2. Formal parameters are ARR, B, and C. And here's my values that I'm passing in. I'm passing in the current value of ARR, which again is going to be a memory location. So I've got a bunch of things now pointing to the same place in memory. B is past the value of B, and C is past the value of C plus 1, which is 3. So now I'm going to execute this method. I come in here, is C less than array.length? It is. Is the array at position C, which is 0, 1, 2, is this here? Is that not equal to B? That's false. It is equal to B, so I go into my else. My else is a return. I return 1 plus, oh, I have to wait, another method invocation. So I get a new activation record, and I'm clearly going to run out of room here, so I'm just going to start putting these on top of each other. I have a new activation record with 3 formal parameters, ARR, B, and C. ARR is sent the value of the current ARR, which is a memory location. B is sent the value of B, and C was 3, and it sent the value of 3 plus 1, which is 4. So now I start executing this method. I get in here, is C less than array.length? It is. So is the array at position C not equal to B? That is true. It is not equal to B. So I execute this if. This if is a return statement, so I return, oh, I have to wait. Another method invocation. So I have another activation record. This again is an activation record for rec method 2, which has 3 formal parameters, ARR, B, and C. That's what's going to go on the top of the stack in my little pile here. ARR is given the current value of ARR, which is a memory location. B is given the current value of B, which is 2, and C is given the current value of C plus 1, which is going to be 5. So now I start executing this method. So I go in here, is C less than array.length? No. C is equal to array.length. So this if test is going to fail. So I will jump down to this else, which just says return 0. So now this current method is done executing. So what happens is this method gets popped off the stack and it's done. So that means the formal parameters and any local variables get garbage collected. So this method's done, and this arrow, which was a formal parameter, is gone. And that value of 0 is returned to where we left off, which is here. So now this method can pick back up, but that was the end of that statement. So this method is also done with a value of sorry, did I miss one here? No, okay, sorry. With a value of 0. So this method activation, this particular invocation is now done. So this gets popped off the stack and garbage collected, along with any local variables and parameters, formal parameters. And the value of 0 gets returned to where we were waiting for it. This method can now resume, which was resumed here, left off here. So we need to pick back up where we left off, which was just a return statement. So we're going to return a 1. And now this activation record is done. This gets popped off the stack, and the formal parameters get garbage collected. We return that 1 to here, right? So here we pick back up with this method. This method pause here, So we continue with that statement. That statement is just a return statement. So now we're going to pop this activation record off the stack and return the 1 to the place where it was waiting, which is here. So now this activation record gets picked back up, which was here. We pick back up with that statement, which is again just a return statement. So we return the value of 2. This gets popped off the stack, and any parameters get garbage collected. Note that the array is not being garbage collected because we still have things pointing to it. As long as there's variables pointing to it, this array will get saved in memory. So the return statement gets sent here. Then this method statement picks back up with where it left off, which was here, which is just a single return. So this method gets garbage collected, and the value 2 would be sent back to our initial invocation and printed in the console. Note that A is still pointing to the array, so it hasn't been garbage collected. Also note that because of how Java passes around objects in general and arrays in particular, if we'd have made a change to any element of that array in any one of those recursive calls, it would have been changed in the one and only copy of the array that's stored in memory, which means it would have been changed for all of those references. So that's something you really have to be careful about, and we talked about that back when we talked about pass by value, but this is just a reminder of that there's only one array that we have all these different variables and parameters pointing to, but it's still just one array. So if I change that array, it changes for everybody. So can you figure out what this method was doing? This method was basically counting how many times this value appeared in the array starting at this position. So if we were to invoke this second call to this method, we would trace the same thing we just did, only C now starts at 2. So we would start looking at our array at position 2. So we'd start looking here instead of starting to look here. So the value of this second recursive call would be 1, because 2 appears only once in the array if we start looking at index 2. Okay? So there is a trace of a recursive method using arrays.